Welcome to the third part of our tutorial series on developing a painterly stylized material. In the first and second part, we developed a procedural painterly base color, a specular, and a stylized shadow. And in this third part, we're going to take care of adding some nice outlines to our sphere. So let's get started.
So I think I'm going to leave the base shader like this now. And we can start talking about something a little bit more complex, which would involve adding outlines to our sphere. So in order to do that, we need to start talking about altering the vertex normals using the world position offset and creating a blueprint actor with two different instance static meshes, one for the base diffuse that we have now and one dedicated to the outline. Okay, so keeping this simple, I'm just going to be duplicating this sphere. And then in the materials here, I'm just going to be adding one more that I'm going to be calling basic outline. Okay, then I'm going to be assigning the basic outline material to my sphere and open it up. Okay, let's start first talking about inflating this sphere. So I'm going to be assigning a very basic color to it, like a pink color. And I also want to make sure that my material is masked and double-sided because we will be playing with its normals. Okay, so first of all, let's start talking about inflating this sphere through the world position offset. So the simplest way of doing this for smooth surfaces like the sphere would be to get the vertex normals, add a multiply that I'm going to plug directly into the world position offset. And then as I start multiplying the vertex normals for higher values like 100, you will see that my sphere will start inflating. So I can play around with this. So for example, if I were to add a Fresnel node with an exponent of 10 and plug that to a step node to make this more contrasty with an x value of 0.2, I would get something like a very basic outline that I would need to invert because I want just to see the outline. And I plug that into the opacity mask, I will basically get an outline. So if in my main map I were to place this on top of the sphere, it would basically look as if this sphere had this kind of outline. But then I would need to select both the object at the same time at all times. So this would get kind of annoying. But you could do this if you wanted to. So a way to group these two meshes together and reduce the draw calls that we would have, because right now we're drawing two spheres rather than one, would be using instance static meshes. And in order to do that, we need to go under blueprints and then right click and create a new blueprint actor. And I'm going to call BP basic outline. All right. And then Control Shift S to save all. Okay, let's open this blueprint actor. So we want to add a instance static mesh component. And we want that instance static mesh to be a sphere. Okay, just the normal sphere will do. And of course, we won't be seeing anything right now because we haven't added that instance yet. So let's go into the construction script and drag in the instance static mesh in here. And then we want to add this instance. And the transform of it, we're just going to get it again. We're going to get the relative transform. And then we're going to plug it into the instance transform. Now, if we compile and save and we go into a viewport, you will see that our sphere would have appeared. So let's go back to our construction script. Now we want to start playing with something called custom data values, which are a way for the blueprint editors and the materials editors to communicate. So we can be passing specific data values to the materials. Out of this return value, let's set a custom data value. Okay, where the target would be our instance static mesh. And then just for the sake of it, let's just add one more instance. Okay, and I'm gonna break this transform because I want to offset it a little bit. And I'm gonna just add an offset to the location. And then I'm gonna make the transform again with the offset. Let's plug all these pins together. And then the return value would be the instance transform. And now I want to plug the executive pin from the custom data value to the add instance, and then duplicate this and plug this here with the same target. So if I compile and save, and I add an X offset of 100, I should start seeing two spheres here. So let's just separate them completely, add an offset value of 500. So now we have these two spheres. And I want them to share one material. Based on these custom data values, I want one instance to be colored white and the other one to be colored black. Okay? So I want the first instance to be colored black, so a custom data value of 0, and the second instance to be colored white, so a custom data value of 1. Okay? And then we need to inform this blueprint actor that we're setting some custom data values through the instance static mesh. So I'm gonna click on the instance static mesh and I'm gonna scroll down until I find the instance tab. And down here in the advanced tab, I would have a number of custom data floats that right now is 0, but we actually are setting one custom data float. Let's switch this to 1. All right, so let's assign to this sphere our basic outline material. So I'm gonna drag up and then assign the basic outline underscore basic outline. Compile. And now they will share this outline material. So let's go back to the basic outline. And for clarity's sake, I'm just gonna unplug both these pins because I just want the base color to be colored differently based on my custom data value. So I'm gonna add a lerp node that I'm gonna be plugging to the base color. And the custom data will be driving the alpha. So if the alpha is 0, the sphere will be colored white. If it is 1, it will be colored black. Okay? So let's get a per instance custom data node, which is the node that communicates with my blueprint actor. So at the data index of 0, which is the one here, it has a custom data index of 0. I will be driving the value that I am specifying either in one instance or the other. So for the custom data index of 0, in the first instance, I'm inputting a value of 0. And for the second instance, remember to plug this return value to the instance index. For the second instance, I am inputting a custom value of 1. Now, if I plug this per instance custom data to the alpha input of my lerp, the default value is 0, so of course the lerp will output A. But if I save and apply my changes, and I go back to my basic outline into the viewport, you will see now that one sphere would be black and the other one would be white. And if I set this custom data value to something like 0.5 now and compiled, my second sphere would be gray. So I'm using this set custom data values to communicate with this basic outline material through the per instance custom data node. I hope that's clear enough. Okay, so we can use this to add an outline to our sphere. Let's just move this per instance custom data a little bit in the middle of our graph. And now we want to have our original sphere to have this pink color that we had decided before, and the outline to be fully white, so have a value of 1. Okay, and then we want the sphere to appear fully solid in one instance static mesh and as an outline in the other instance static mesh. So I'm going to add another lerp, and I'm going to say for my solid sphere that is pink colored, I want this lerp value to be 1 because I want this to be fully visible. And for the B, I want this to be just the outline. And then I'm going to plug this to the opacity mask and nothing should change. Okay, because the default value of the per instance custom data is 0. Okay, now we want the sphere to be inflated only on our second instance static mesh. So let's lerp this again. I don't want my solid sphere to be inflated. I just want my outline to be inflated. So my first lerp should be 0 because I don't want this to be inflated at all. And my second one should be inflated. And now I'm going to plug this to the world position offset. Save. So now if we did everything correctly in our basic outline actor, we should see in the viewport one outline and a normal solid sphere, which is perfect. And right now they're offset from each other just because we had added this offset here when we broke the transform. If we plug the relative transform of the instance static mesh directly into the second instance, and then we delete this and compile, you will see that our sphere now will have an outline. So if I go back to my stage and plug my basic outline blueprint in, you will see that my sphere will just be one mesh, but with the outline together. But we still have an issue here with the shadow because my outline is actually drawing the shadow on the floor. And I don't want that. I would like my shadow to appear to be just a solid sphere. So we have two ways of dealing with this. Either we use the shadow pass filter that we already saw when creating the stylized shadow for our sphere, or we flip the normals of the second instance static mesh that is responsible for the outline so that the outline is basically treated as if it were the inside of the sphere, and so it is not rendered in the shadows. And I'm gonna go with the second option just to show you an alternative way of dealing with this. So let's go back to our basic outline here. And before we pass this Fresnel into the lerp, we want to actually multiply it for the flipped normals. So I'm gonna plug this 1 minus node into the A input of our multiply, drag this a little bit down because we'll need a bit more space. And then I will get a two-sided sine node, which gets my normals of the sphere, and I'm gonna invert it with a 1 minus node. If I plug this into the B, and then the output of the multiply into the lerp, and then I save and go back to my stage, you can see now that I can see the outline perfectly fine, but it is not rendered in my shadow, and that's exactly what I wanted. Okay, so I hope this gave you a basic understanding of the custom data values as well as inflating the normals of a mesh through the wall position offset to create an outline. Now let's apply what we just learned into our painterly material. So I'm just gonna delete this basic outline blueprint, and then I'm gonna go under blueprint. So since we have this basic outline blueprint actor already set up, I'm just gonna right click and duplicate it. And I'm gonna call it BP underscore painterly shader tutorial. Okay, I'm gonna save, double click on it. I can close these two now, and then I'm gonna click on the instance static mesh and change the material assigned to it from basic outline to painterly shader tutorial. And now you will see my sphere, even though there will be actually two spheres because we have two instance static meshes, one on top of the other. But we have no custom data set up in our painterly material, so we're not seeing any outline yet. So let's take care of that. I'm gonna go to my painterly shader tutorial material and set up the outline. All right, so as we did with the basic outline material, we first want to take care of creating an outline mask that we're going to be plugging into the opacity mask of our material. The process is going to be similar to the creation of the inner rim erosion, but of course we won't be reversing it at the end. So we're going to be keeping the outline mask. So let's select the vertex normals, the curvature filter, camera vector, dot product, the absolute, and the multiply. And then I'm gonna Control C to copy, and then Control V to paste it right below it. Okay, so we want to plug the absolute node into the multiply and saturate right away to clamp these values to a 0 to 1. Then we want to multiply this again. Again, here we're just remapping this value to having a stronger or less strong outline mask. And you can play around with these values as much as you like. For now, I'm gonna set the multiply to 4.5 and then saturate again. At this point, we can soften a little bit what we've got and then use a power node of 1.5. And I'm just gonna start previewing to give you an idea of what we're getting. And after the power node, like we did with the erosion, I'm gonna add a step node to define my outline. Now, rather than specifying a value here, I wanna do something else. So first of all, let's press S on the keyboard and click in an empty area of the graph to create a scalar parameter that we're going to be calling outline width. And I'm going to set it to a low value of 0.1. Let's then add a lerp. So what do we want to drive here? If I right click and start previewing the step node, you can see that when the step node is at 1, it's giving me a fully white output. And as soon as I start putting it below 1, like 0.8, is giving me a very strong, hard-edged outline. And if I go above 1, then it's giving me just the full white. So we want this lerp to be driving the value of the step. For our solid instance static mesh, we want a value of the lerp of 1. And for our outline instance static mesh, we want the value of the lerp to be 0.1, because a step of 0.1 is going to give us a really nice outline. Okay, now what's going to be driving the lerp? Well, that's the instance custom data. So let's plug this into the alpha, and then I'm going to add a multiply node here and plug the output of the lerp into the multiply A input, just to add a little bit of offset to different outlines in case you want to have more than one. I'm just gonna have a per instance random, which basically outputs a different random float value based on the instance static mesh components that we have in the blueprint actor. And then I'm gonna add to it a low value like 0.5 and plug that into the multiply. Okay, now let's plug the result of the multiply into the x of the step. And as we did for the erosion, we want to be multiplying the step output with the curvature filter. And this time we don't want to invert that, but this is going to go directly into our opacity mask. So let's drag out of the multiply and add a name reroute declaration node that we're going to be calling outlines. Okay. And then I'm just going to select all the nodes and I'm going to call this outline mask. Okay, now that we have the outline mask, we want to go in here and we want to add a lerp before the shadow pass switch. So let's plug this into the default. And we want to get the per instance custom data again and plug this into the lerp. So for our solid instant static mesh, we're just going to use our inner rim erosion output, which is what we had before. And for the outlines, we want to just get the outlines. And now we can save. Perfect. Now if we check out our blueprint, we can see that we start having the result we want. But we have no way of inflating the mesh, so we cannot manipulate the offset of the outline from the solid sphere. In order to do that, we'll need to plug something into the wall position offset like we did in the basic outline material. So let's go back to our painterly material, and below the outline mask, let's take care of inflating a little bit the mesh. So rather than using the vertex normals here, like we did to create the basic outline material, I'm going to use a different set of nodes that would work also on objects with flat planes, like the cylinder or the cube. And we used that set of nodes before already when setting up the shadow. So let's just copy this absolute warp position, object position, subtract and normalize node, and then paste them down here. All right, so basically this set of nodes completely replaces the vertex normals. And if you remember, when we're setting up the basic outline materials, we basically just multiplied the vertex normals for an inflatable amount. So let's do that here as well. So I'm just gonna hit M to add a multiply node, and then I'm gonna multiply the normalize for a scalar parameter. So I'm gonna press S on the keyboard and add a scalar that I'm gonna call outlines general offset. And I'm gonna give it a value of 3. And then I'm gonna plug it to the B of the multiply. Okay, at this point, I know I'm going to be adding more than one outline to my painterly shader. And that's because I want to give it this sketchy look as if somebody actually tried to trace over the outline multiple times. So I'm going to get another per instance random node, and then I'm going to multiply it for quite of a high value to amplify it. Something like 10,000. Okay, at this point, I'm going to get the fraction of this value. And then I'm going to remap it. I'm going to scale it up by adding to it a value of 1.25. And then I'm going to subtract it. This is just to create more randomness to it. And it's going to sound like as if I'm just spitting like random numbers, but those are actually values that I've tested out and gave me the result that I wanted. After this tutorial, you're really encouraged to just go in and type in different values just to see different result that they could output. So we're going to subtract to the fraction a value of 0.5. And then we can multiply the multiply and the add node. And for the subtract node, I actually want to take care of adding a directional offset to my outlines so I can shift them in each direction of the axis. And for that, I will need a vector 3 parameter. So I'm going to press 3 on my keyboard and click in an empty area of the graph, and then right click and convert this to parameter. And I'm going to call it outline directional offset. This is going to have a value of 0 in the x-axis, 1 in the y, and 0.6 in the z. And then I'm going to multiply it for another scalar parameter. So I'm just going to right click on the B and promote to parameter. And I'm going to call it single outline difference in case I just want to shift the outlines independently. I'm going to add a default value of 5. Okay, now we can multiply this subtract node with the multiply node for the directional offset. And then we can multiply this value further, the one that we multiplied with the add node, to a value of 0.8. Okay, at this point, we can just add these two multiply nodes, and we will be done with our inflate setup. So I'm just going to drag out of the add node, and I'm going to add a name reroute declaration node that I'm going to call inflate. Let's select all of these nodes and then comment and call it Inflate Settings. All right, so at this point, we need to plug the inflate into the world position offset. But before doing that, we want to make sure that this just affects the outline instance static mesh, not the solid one. So let's add a lerp node and a per instance custom data node that we're gonna plug to the alpha. So when we're dealing with our solid sphere, we want our normals to stay intact as they are. We don't want them to be inflated. And in order to do that, we need to take this group of nodes, which basically identify our normals. So I'm just gonna select the absolute world position, object position, the subtract within the two, and the normalized node, Control C, and then I'm gonna paste them here and connect them to the A of the lerp. And the B is just gonna be our inflate. So basically we're saying if we're dealing with our solid instance static mesh, then we want our normals to be as they are, else we want them to be inflated. So we have an inflated outline. And then we can plug this to the world position offset. So let's take a look at how this looks like. So it's looking a little bit weird, and we have just one outline here. So it looks as if there is something like a shadow impacting our sphere. And why is that? If you remember correctly, in our basic outline, we actually flipped the normals so that there was no shadow cast on the ground. And right now there is a shadow cast on our solid sphere, and that's from the outline. So let's go to our painterly material and deal with that. Rather than flipping our normals, I'm going to deal with this differently this time. And I'm just going to make the shadow of my outline material completely transparent. So let's go into our shadows set of nodes. And down here, right before we go into our name reroute declaration node, I'm going to add a lerp node. So let's plug the output of the add node into the A and the lerp into the shadows. And then let's get a per instance custom data node and plug it into the alpha. So we're doing the opposite of what we did for the outline lerps. We're saying if this is the solid material, then I do want the shadow to be there. But if this is the outline material, then I want my sphere to be completely invisible. So here the lerp B value should be 0. Okay, now if I save and go back to our printed material, you can see that it's looking like we want to. And we have only one outline, but we can add one more. If we go into our construction script, copy these two nodes, add instance and set custom data value, and drop them down here. We need to plug the get relative transform into the instance transform, the executive bin into the add instance, and then the instance static mesh needs to be the target self of the add instance node, and this reroute will go into the target of the set custom data value. So now if we compile, we can see that we have two outlines, even though they're one on top of the other. But if we go back to our painterly material and scroll down to the single outline difference and set it to a high value, like 50, then save and go back to our painterly blueprint, then you can see that they start being offset from each other. And it's looking pretty cool. So now let's go back to our map and we can delete this sphere and change it with our blueprint actor with the outlines.
Okay, thank you for sticking around until the end of the third part of this tutorial series. And in the next one, we're going to be looking into adding some sketched and smudged rims around our sphere. See you there.